السلام عليكم يعطيكم العافية شباب. I have to start. I cannot wait. We just have 17 students. There are around 10 students not logged in now. Anyway, let us to go back to the last part. We are still in section 17.2, the complex numbers. And the last thing where we stopped last time اللي هو the Demover's formula for finding the power. Regarding the polar form of any complex number z, if we have any complex number z is equal x plus iy, we wrote z as cosine theta plus I sine theta, which is e to the power I theta. الآن e to the power I and theta, I theta to the power n, then you have to multiply n here, that becomes e to the power I n theta. الآن cosine I e to the power I theta هي عبارة عن cosine theta plus I theta to the power n, because e to the power I is equal cosine theta plus I sine theta. Then the right hand side here عبارة عن that becomes cosine n theta plus I times n sine of n theta. That's called Demover's formula. Now this one, it will be very helpful. For example, if you would like to find cosine pi plus I في sine pi to the power 100, for example, that becomes cosine 100 pi plus I في sine 100 pi. So it's rather than to multiply this one by itself 100 times, you can just use it in one single step by using this formula. Let us to see some examples about the Demover's formula. The example says use the Demover's formula to derive the trigonometric identities for cosine 2 theta and sine 2 theta. For cosine 2 theta and sine and 2 theta. From those, you will see that n is equal to. All right. Now apply Demover's where n is equal to, that means cosine theta plus I phi sine theta square. It should be equal cosine 2 theta plus I times sine 2 theta. Now, when you simplify the left-hand side, becomes cosine square theta plus 2i times sine theta, cosine theta plus sine square theta is equal cosine 2 theta plus I في sine 2 theta. الآن الريال part بالleft hand side is equal real part بالright hand side, والimaginary is equal imaginary. This implies cosine theta, that implies cosine theta sorry, here we have I square. I square, it is minus 1, so that becomes cosine square theta minus sine square theta plus I times 2 sine theta cosine theta to be equal right hand side cosine 2 theta plus I في sine 2 theta. The real part is equal real part. The imaginary بتساوي imaginary. Real part, this is implies cosine square theta minus sine square theta, which is the real part on left hand side, is equal real part, which is cosine 2 theta. The imaginary is equal to imaginary. 2 sine theta cosine theta is equal to sine theta. Cosine theta is equal sine 2 theta. And we know those two identities from calculus 1. هذه متباينات بنعرفها احنا من الكالكولس 1 اللي هي كوزين 2 ثيتا is equal cosine سكوير minus sin سكوير وساين 2 ثيتا is equal to sin ثيتا cosine ثيتا. Any question about this example? أي سؤال على هذا المثال؟
نعم دكتور. ليه حطينا الساين 2 ثيتا بإيماجينري ما خلينا الكوزين 2 ثيتا هي الإيماجينري؟
ما هي الإيماجينري؟ طيب الجزء اللي مضروب فيه I.
بس هو في السؤال مش حدد يا دكتور. هو قال identify for cosine 2 theta and sin 2 theta.
You need to find the identity for cosine 2 theta or sin 2 theta. So this is sin 2 theta and this is cosine 2 theta. الريال بارت على اليسار بده يساوي الريال بارت على اليمين والايماجينري على اليسار بده يساوي الايماجينري على اليمين.
تمام.
طيب خلينا نعمل الان just to see the following remark. هلا احنا بنعرف انه in algebra we know that minus 2 and 2 are the square root of the number 4. يعني the square root of 4 is equal either minus or plus 2. That is in algebra. Why? Because minus 2 square is equal 4 and 2 square also is equal 4. الآن that means the square root of 4 are distinct solutions of the equations w square is equal 4, because this one implies w is equal what? Is equal positive negative square root of 4, which is positive negative 2. All right? طيب, that's we know this one from algebra. Now remember that if x is a positive real number, then it has two square roots, one positive and the second one is negative. Like the number 4. 4 is a positive real number. It has two square roots, minus 2 and 2. طيب الآن we denote the positive square root of the positive real number x by positive square root, or x to the power half. طيب الآن إذا two roots راح يكونوا عندنا the two roots of any positive real number. It should be positive. It should be positive negative x, positive negative square root of x. Sorry. أيوة يعني مثلا الأربعة the square root of 4 is equal 2, but negative square root of 4 is equal minus 2. الآن if x is any positive real number and n is positive integer, positive integer, I mean natural number, there is a unique positive real number s such that s to the power n is equal as x. What does this mean? That means s it should be what? X to the power 1 by n. This is just to recall how we can find the roots. But in complex number, the equation is totally different. For example, a number w is said to be an nth root of the non-zero complex number z if w to the power n is equal z. Why? Because in this case, the nth root of positive complex number z, which is written in the polar form r times cosine theta plus I fi sine theta, are given by. الآن, here I will explain how we can find the nth roots of any non-zero complex number. First of all, I have to write down my complex number in polar form, in the form r times cosine theta plus I في sine theta. هلا ال WK is equal r to the power 1 على n times cosine of theta plus 2k pi divided by n plus I في sine of theta plus 2k pi n. But the values of k, it should be started from 0 until n minus 1. n minus n is the number of the roots which is required. يعني هلا to solve for example w cube is equal I, it means here n is equal 3. That means you should take k is equal 0, 1 and 2, because 2 is equal 3 minus 1, which is equal n minus 1. In this case, when you substitute the value of k is equal 0, you will get the first root. K is equal 1, you will get the second root. K is equal 2, you will get the third root. طيب خلينا نشوف الآن some examples. الإكزامبل بيقول find the 3 cubic roots of z is equal I. Here I mean solve w cube is equal I for w. يعني that's what do we mean by this one. Or w is equal I to the power 1 by 3. We need to solve this equation. الآن my complex number z, first of all, here n is equal to 3 because the cubic roots, 3 cubic roots. The complex number z is equal I. I need to write it in polar form. Here r is equal modulus z, which is 1, because modulus I is equal 1. And where is this complex number located? I, it is here. How much is theta? Is equal pi over 2. So theta is equal pi over 2. Now I need to solve this equation. WK, according to the formula to finding the kth root, is equal R, which is 1 to the power 1 by 3, times cosine pi over 2, which is theta, plus 2k pi divided by 3, plus I times sine of pi over 2 plus 2k pi divided by 3. But now I have to take different values of k. K, it should be 0, 1, 2. Now, when we substitute each different value of k, I will get a different root. هلا w, when k is equal 0, w naught هلا is equal 1 to the power 1 by 3, it is 1. So that becomes cosine. When k is equal 0, 0 and the pi over 2 divided by 2, divided by 3, plus I في sine pi divided by 2 divided by 3, which is equal cosine الباي على 6 بده يصير هو جذر الثلاثة على 2 square root of 3 by 2 plus I والساين لإلها بده يساوي عبارة عن نصف. So this is the number W naught. الآن this is when k is equal 0. When k is equal 1, you will get W1, which is cosine. Now substitute here k is equal 1. Pi over 2 plus 2 pi divided by 3. All of them. Plus I في sine pi over 2 plus 2 pi by 3. and this is becomes which is equal cosine. هلا باي اوفر 2 بلس 2 باي بده يصير معنا 2 بصير 4 باي زائد 1 5 باي على 5 باي على 3 على 2 على 6 يعني 2 ونص باي بصير 5 باي على 6. طيب بلس اي في ساين 5 باي على 6 واللي هي تساوي ماينس جذر 3 على 2 بلس اي تايمز هاف.
Doctor, I should make all the steps, so I can just bring the final answer. Do the,
No,
like
the step.
no, the key 0 I can do the steps, and the others k I have to do also the steps.
Yes.
Okay.
هلا last root when k is equal to w2 is equal cosine pi over 2 plus 4 pi divided by 3 plus I times sine pi over 2 plus 4 pi divided by 3 ويساوي 8 زائد 1 بصير عندنا كوزين 9 باي على 6 plus I times sine 9 باي على 6 واللي هي عبارة عن 0 minus I وتساوي minus I. الآن have a look here. when we plot the complex number square root of 3 by 2 plus I times half, which is W naught, it will be its location here somewhere. This is the value of R. I mean a circle with center 0 and the radius R, which R? R is the modulus of the complex number Z. And this is the location of W1. And this is for W2. You will notice that the three roots will divide the circle with center 0, 0 and radius R into three different, into three equally parts. I mean this part, it is equal this part, which is equal this part. يعني الثلاثة روتس بدنا نقسم الدائرة اللي مركزها 0 0 ونصف قطرها R إلى ثلاث أقسام متساوية. In case we have four roots, they will divide the circle into four equally parts. In case we have five roots, the complex number will divide the circle into 5 equally parts. We will see now the next examples how is this working. Elam, you will see that W naught to the power 3 is equal W1 to the power 3, which is equal W2 to the power 3, which is all of them is equal how much? I. Any question about this example? Type. Find the fourth roots of Z is equal 1 plus I. طبعا enough space. الآن here n is equal 4 والcomplex number is equal 1 plus I. Now R is equal modulus 1 plus I, which is square root of 2. هلا where is 1 plus I located? هذا هون. واحد من الX واحد من الY, this complex number, وهذه عبارة عن مين؟ باي على 4. Here theta is equal pi over 4. Now WK بتساوي R to the power 1 by N في cosine theta plus 2k pi divided by N plus I times sine theta plus 2k pi divided by N, will K is equal 0, 1, 2, 3. طيب. Now we have to find those 4 roots. بدنا نوجد الآن الأربع جذور هذول اللي عندي. هلا when K is equal 0 you will get W naught. R, how much is R? Square root of 2 to the power 1 by 4 times cosine theta, which is pi over 4 divided by 4 plus I في sine الباي divided by 4 على 4 بهذا الشكل ويساوي هلا square root of 2 it means 2 to the power half times 4 1 by 4 بيصير معنا 2 to the power 1 by 8 times cosine الباي على 16 plus I في sine الباي على 16. Of course you have to use the calculator to calculate it. Allowing K is equal 1, K is equal 1, W1 بده يساوي معنا 2 to the power 1 by 8 times cosine. When you replace K is equal 1 بصير معنا pi over 4 plus 2 pi على 4 plus I في sine الباي over 4 plus 2 pi على 4 which is equal 2 to the power 1 by 8 times cosine 8 باي زائد على 9 باي على 16 9 باي على 16 زائد I في sine 9 باي على 16 of course you have to calculate it by using the calculator. هلا when K is equal 0 1 2 W2 بده يساوي معنا again 2 to the power 1 by 8 cosine الباي على 4 plus 4 pi على 4 plus I في sine الباي على 4 plus 4 pi divided by 4. When you simplify 2 to the power 1 by 8 cosine 4 16 بيصير 17 باي على 16 زائد I في sine 17 باي على 16. Of course we have to do the calculation by using the calculator. الآن when K the last one K is equal 3 W3 بتساوي 2 to the power 1 by 8 cosine pi over 4 plus الآن when K is equal 3 بده يساوي معنا 6 pi على 4 plus I في sine الباي على 4 plus 6 pi على 4 which is equal 2 to the power 1 by 8 cosine 6 ب 24 25 باي على 16 plus I في sine 25 pi divided by 16. Of course, we have to use the calculator to calculate it. It's very simple and straightforward to find out the roots as long as you find the value of R is correct and the theta, I mean the polar form of your complex number correct. Any question here for this example? Any question?
No, thank you. It's all clear.
All right. نشوف the next examples. Find all solutions of the equation z square plus 1 is equal 0. طيب. Here when we said that z square plus 1 is equal 0 implies إنه z square is equal minus 1. Therefore, z, it should be what? Minus 1 to the power half. Okay? طيب. الآن my complex number اللي هو خليني let us to call this complex number z naught is equal minus 1 because this is the part which is I have to find its roots. Then the value of r is equal modulus z naught, which is modulus the minus 1, which is 1. Also theta is equal what? Is equal pi, because this is the location of this complex number, minus 1. Here z naught. Now I need to find the second roots for this complex number z naught. So here the value of n is equal to will r1 with theta is equal pi. All right. هلا بدنا wk بتساوي r to the power 1 by n times cosine theta plus 2k pi divided by n I times sine theta plus 2k pi divided by n. But the values of k here is equal just only 0, 1 because the value of n is equal to. Therefore, W naught you will get it when k is equal 0. R, how much is R? R1 to the power half cosine theta, which is pi, divided by n, which is 2, plus I في ساين الباي over 2 واللي هي عبارة عن كوزين الباي over 2 عبارة عن 0 وساين الباي over 2 1 times I بيعطيني I, so the first root it will be I. هلا second root when k is equal to you will get w sorry 1 is equal w1 واللي هي عبارة عن 1 to the power half cosine pi plus 2 pi divided by 2 plus I في sine pi plus 2 pi divided by 2 وهذا بدي يساوي cosine 3 pi على 2 0 plus I في sine ال 3 باي على 2 اللي هي زي ماينس ساين الباي على 2 واللي هي ماينس 1 times I, it will be I times minus 1 which is minus I. So the only two roots or the solution here z is equal minus 1 to the power half. It has two roots واللي هي either I minus or positive I, negative positive I. And of course here we have to take a negative or positive roots. Any question for this example? Okay, do the next example. Find all solutions of the equation z to the power 4 is equal minus 1. Z to the power 4 is equal minus 1 is equal 0. طيب الآن first of all السوليوشن لهذه المعادلة z to the power 4 minus 1 is equal 0. That implies z to the power 4 is equal 1, which implies that z, it will be 1 to the power 1 by 4. طبعا راح ناخذ البوزيتيف والنيجاتيف of course لأنه even. الآن انتبهوا لعندي لهون. I need to recall this number to recall it again. Z naught is equal 1. Then the value of R is equal modulus Z naught, which is modulus L1, which is equal 1. With theta here is equal 0 because this complex number, it will be here somewhere. اللي هي 1. هلا n is equal 4. الآن you will see WK بتساوي معنا الآن R to the power 1 by n، يعني 1 to the power 1 على 4 في cosine 0 plus 2k pi divided by 4 I في sine 0 plus 2k pi divided by 4, where the values of k is equal 0, 1, 2, and 3. So 1, 2, 3. طيب. Now substitute the values of k. When k is equal 0, you will get W naught, which is cosine of 0 plus I في sine 0. Cosine 0 is equal 1 plus I في 0, which is here equal 1. Again, k is equal 1 implies W1, which is cosine, because 1 to the power 1 by 4, it is 1. Cosine 2 pi على 4 واللي هي pi على 2 plus I في sine الباي على 2 واللي هي cosine الباي على 2 0 I في 1 which is equal I. Continue. When k is equal to W2 بتساوي cosine 4 باي على 4 بتساوي الباي plus I في sine الباي which is minus 1 plus I في 0 which is minus 1. هلا the last one when k is equal to 3 you will get W3 هي عبارة عن cosine 6 باي على 4 اللي 3 باي على 2 3 باي by 2 plus I في sine 3 باي over 2 cosine 3 باي over 2 اللي هي 0 plus I في minus 1 واللي هي minus I. So the solution is of z to the power of 4 minus 1 is equal 0. The solutions are لأن ال 1 وال I minus 1 و minus I. Those 4 roots. Okay. Any question here? أي سؤال هون؟ طيب نشوف ال last example بيقول لي find all solutions of the equation z square plus 2z plus 2 is equal 0. This example here you can solve it by the equation minus b minus plus the square root of b square minus 4ac divided by 2a, which is equal minus 2 minus plus the square root of b square اللي هي 4 minus 4 في واحد في 4 times 1 times 2 divide by 2 times 1, which is equal here minus 2 minus plus square root of 4 minus 8, all of them divided by 2, and that becomes minus 2 minus plus square root of 4 minus 8 اللي هي minus 4, all of them divided by 2, which is equal minus 2 minus plus square root of minus 1 بالsquare root لل4 على 2, which is equal minus 2 minus plus square root of minus 1, it is I, times 2 divided by 2, and that's equal minus 2 plus 2I divided by 2, and minus 2 plus minus 2I divided by 2, which is finally equal here. When you divide, becomes minus 1 plus I and minus 1 minus I. Any question here for this example? Any question? Type. Section 17.2 already done. Now we will go to section 17.3 as far as I know. This is a very short section here. Just we would like to learn what's the meaning sets in complex number. Especially here we will talking about the circles in terms of complex number, and the properties of the set when it is open, closed, connected, bounded, domain, region. This is just a concepts. فقط عبارة عن مفاهيم بدنا نتعلمها هنا about the sets للمجموعات. طيب. All right. This is a very short section. الآن here we will talking about mainly about the domain in the complex plane. It has to remind you from calculus 1 that in math 101, when I gave you this example to find the domain of the function f of x is equal 1 by square root of x minus 1. How you will find the domain in real number for this function? You remember that the domain, it should be, this is a square root. It should be what's inside the square root is greater than or equal 0. But since it is located in the domain, all the values of x such that x minus 1 should be greater than 0, which means the interval from 1 to infinity. We cannot take x is equal 1, it will be zeros of the denominator. صفر للمقام, which is not acceptable. الآن, if you remember in calculus 3, math to 11, when we ask you to find the domain of two variable function, of the function f of xy is equal to 1 by square root of x minus y. Here to find the domain, it should be the domain here for the function of two variables as a pairwise, أزواج مرتبة, pairwise, which is in the plane R square, such that here you should to make sure what's inside the square root positive, it should be x minus y greater than 0, which means all the pairwise such that in R square, such that x is greater than what? Y. Now, what's the difference between the domain of those two? When the function is single variable, it is domain on the real number, on the real line. This is the domain. But for a function of two variables, the domain, it will be on the plane. على المستوى اللي معي. How? This is x, this is y, and this is z. First of all, you have to sketch y is equal x and to see where is x is greater than y, in which side it is located. يعني in general, for the line y يساوي x, have a look here. This is x-axis, this is y. This is y is equal x. X to be greater than y, where is it? Any point located here, for example, it will be مثلا 2 1. So this one here, the x coordinate is bigger than y. So this domain, when x is greater than y, it will be located here. In this part. اللي هي على right hand side of the line y is equal x. فالآن to sketch the line y يساوي x, this is the line y is equal x. So domain, where this domain becomes, وين هذا الدومين بده يصير معي؟ It will be this region here. This is the domain على البلين. هون عبارة عن ال x is greater than y. Any point located here, x is greater than y. طيب الآن خلينا نشوف the equation of circle and how we can sketch the circle in complex number. I mean the domain of this circle in complex number. In case we have the complex number z naught is equal x naught plus I times y naught, and z is equal x plus iy. الآن when we make the distance between z and z naught, it is the modulus, which is according to the distance function, is equal to this equation اللي هي square root of x minus x naught square plus y minus y naught square, which is the distance between z naught and z. طيب الآن equation modulus z minus z naught is equal r, where r is greater than 0. This one will be lies in the circle with center z naught and radius what? R. How? In case I have this complex number here, z naught, the distance between z naught and this complex number here, z, this distance is r. Is equal r. All right. الآن if we make z naught is the center of a circle, then z naught becomes within the circle with center z naught and radius r. But let us to see how is this becomes a circle with me. خلينا نشوف الآن. This is a circle with center z naught and radius r. So z, it is within the circle. But mathematically, how is this one working? When we said that modulus z minus z naught is equal r, that means r is equal square root of x minus x naught square plus y minus y naught square. Now square both sides becomes what? X minus x naught square plus y minus y naught square is equal what? R square, which is here. We know this one, it is represent what? A circle with center x naught pairwise الزوج المرتب x naught y naught, which is the complex number z naught, and the radius r. طيب خلينا نشوف الآن some examples. بقول لي find the equation of a circle with center z naught is equal 1 plus minus I and radius r is equal 5. How we can do this one? We need to write down the equation of this circle. The equation of the circle عبارة عن مين؟ اللي هي Z minus Z naught modulus is equal R, which is Z minus Z naught, it is 1 minus I modulus is equal R, which is 5. But this one can be written in another form, which is like this one form here. How? Assume Z, it is X plus IY. So that becomes square root of X minus 1 plus Y minus 1, please, plus 1. This is square is equal 5, which is X minus 1 square plus Y plus 1 square is equal to 25. أجد كلير هذا المثال؟ واضح هذا السؤال؟ مثال عفوا.
Yes, clear.
دكتور قبل الواي مش المفروض
Yes.
في اي تحت الجذر؟
ايش؟
واي بلس 1 سكوير مش المفروض قبلها اي؟
لا ما في. أخذناه قانون المسافة الحضرة الماضية.
ايوه صحيح. شكرا دكتور.
على حي الله. Any more questions? طيب نشوف الآن. بيقول لي sketch the graph of the equation z plus 1 minus z plus 1 minus 2i is equal 1. This is very simple to sketch it because just write it in the form z minus z naught. Z plus 1 minus 2i, 1 is equal. This becomes z minus 1 plus 2i, which represents circle what? Circle with center z naught is equal minus 1 plus 2i, radius r is equal 1. So how we can sketch it? Very simple. Where is the complex number z naught is equal minus 1? And 1, 2, 2i. It becomes here this complex number z naught. Z naught minus 1 plus 2i. With radius r is equal 1, so this distance also is equal 1. إذا هون بدها تصير مع السيركل الآن. This is r is equal 1. شوف اللي بعده بيقول لي sketch the graph of the region of the equation modulus z is equal 1. How we can say modulus z. هلا modulus z is equal modulus ل z minus 0. إذا الآن هذه بتمثل معي إيش؟ circle with center z naught بتساوي 0 radius r بتساوي معي 1. The complex number z is equal 0 and the radius r is equal. إذا هذه بتمثل معي بهذا الشكل. Circle with center z naught is equal 0 and radius 1. Which is those points here are located on this red lines. All of these points, their modulus is equal 1. And just to remind you that the points inside the circle are what? Modulus z أقل من 1, which is the one which is inside the circle. On the boundary of the circle, it is z, modulus z is equal 1. Outside the circle here is modulus z is greater than 1. طيب خلينا نتحدث الآن عن النيبرهود. Because we have to finish this section. This is a very just a definitions, nothing else. نمشي واحد. شوف النيبرهود. الآن the points z that satisfy the strict inequality z minus z not أقل من rho, less than rho, lies within and not on the circle of radius rho centered at the z point. This set is called neighborhood of z naught, which is we were talking here. When we have this number is z naught, لو بيكون عندنا هذه z naught, neighborhood is the point which is inside the circle. I mean, this is z naught. And if we have this circle with radius r, now the point in which is not on the boundary of the circle but inside the circle, all of these points will satisfy the equation z minus z naught less than rho, because rho is the radius. Type interior points, we call the number z naught is an interior point of a set S in the complex plane if there exists some neighborhood of z naught that is lies entirely within S. What does this mean? What does this mean? خلينا نشرحها هون. Suppose that we have this set in complex number S. This is the set S. We will call this complex number Z naught is in the interior of S if I can find a neighborhood around this Z naught and the total neighborhood inside S. Type. What's the meaning boundary points for any complex number? here this is شايفين interior of S. It will be something inside. All the points inside. الboundaries is the points where it is located at the boundaries of the sets S. I mean, if every neighborhood of Z naught of a set S contains at least one point of S and at least one point not in S, then Z naught is called the boundary point of S. How? Have a look here. When we make, this is the boundaries. هلا الcomplex number here Z naught will be called at the boundary because if you take any neighborhood around the Z naught, you will have a point from the set of complex number S, and there is also some points from outside the set S. طيب الاكستيريور عزة الله لا إله إلا الله ولا حول ولا قوة إلا بالله. A point Z that is neither an interior nor boundary of a set S, it is called exterior. And this is any point here, it is called exterior. طيب, what's the meaning open set, closed set, and connected set? In open set, if every point Z on the set S is an interior point, then S is said to be an open set. Or in other words, S is open if it does not contain any of its boundary point. The set S is an open set if it does not contain any of its boundary points. The closed set is the set which contains the boundary points. نسميها closed set. طبعا هو هذا مش مطلوب منكم كثير بصراحة، لأنه هاي بتخص التوبولوجي تبع الكومبلكس نمبر والأشياء هذه، وهاي بدرسها أنا للطلاب السنة الرابعة في الرياضيات بطريقة ثانية غير هيك يعني، وفي عليها شغل كثير. طيب نشوف الآن الكونكتد set. What do you mean by connected set? We say that if any pair of points Z1 and Z2 in a set S can be connected by polygonal line that consists of a finite number of line segments joined end to end that lies either in the set S, then the set S is said to be connected. We say that the set is connected if I can connect any 2 points inside this set by polygonal line. The polygonal line, it contains a finite number of lines like this one. This is connected because any 2 points, for example here, if I have another point and here another point, I can say this way, we can connect it in this way. طيب الدومين, a non-empty open connected set is called domain. If open set is connected, then it is called domain. يعني لو أخذنا المجموعة هذه We have here Z1 and here Z2. Can we connect those two lines and is it still inside my set S? No, this is not connected. Any open set also connected in the same time, it is called domain. بنسميها domains. يعني كيف؟ The boundaries are not included, so it is boundary. It is open, sorry. Also, any 2 points here in this one, any 2 points, you can connect it. So this one is domain. Because it is open set, the boundaries are not included. Also, have a look at the second example. Also, this is domains. Why? Because it is open, the boundary is not included, and any 2 points can be connected. So this is domains. Type. A region, what's the meaning of region? A region is a domain in the complex plane together with all, some, or none of its boundary points. الريجن بيكون لنا عبارة عن domain. A region is a domain in the complex plane together with all, some, or not of its boundary. يعني this one here it is region. This one is region. Why? Because this set is it is basically connected. You can connect any 2 points. Also, it contains the boundaries. So this is called region. Or it's not necessary all the boundaries to be included, but maybe some of the boundaries. This set here is connected. It has some of its boundaries. So this is region. But what? But this one is not domain because it contains some of the boundaries. Also, this one is not domain because it contains some of its boundaries. Just to finish, this is the last concept, and we will finish the class, inshallah, with this section. But finally, we say that the set S in a complex plane bounded if there exists a real number R is greater than 0 such that modulus Z is less than R. We said that the set S in a complex plane is bounded if there exists a real number R is greater than modulus Z less than R for each complex number in Z. I mean, the modulus for any, if there is a constant R greater than 0, where the modulus of any complex number inside the set S, it is modulus less than R, the same constant, then it is called bounded subset. نسميها bounded subset. All right. طيب. شوفوا هون. This is modulus Z أقل من R. And we took this is S only. So this S here, any complex number inside this S, it is modulus, it is less than R. So this is S, this set of complex number S is bounded set. طيب خلينا نشوف الآن which one of those is open, closed, connected, not connected, and so on. Maybe we'll take 5 minutes from your time. First of all, this is the graph of imaginary z less than 0, lower half plane. This one here is open set, because the boundaries, the x-axis is not included. Number 2, it is not closed. Number 3, is it connected? Yes, it is connected set. Number 4, it is bounded. Bounded here? No, it is unbounded. Is it domain? Yes, it is domain. Region? Yes, region, because it is open. طب المجموعة هذه بتحقق شروط ال A, it is open. Not B, يعني not closed. Connected, yes. Connected, تحقق C. رقم D, bounded, no, because the curve set goes to infinity or minus infinity. Not D. Is it domain? Yes, domain. اللي هي معنى E. Is it region? Yes, region. It is. طيب نشوف المجموعة هذه اللي عندي هون. It is open but not closed, not B. It is connected because you can connect any 2 points by, but it is unbounded because it goes to infinity and minus infinity, not D. Is it domain? Yes, domain. A, B, C, D. It is E. Origin? Yes, it is region. And last one, is it open? Yes, for sure it is open. The boundary is not included. Not closed, وبالتالي not B. Connected. Is it bounded? Yes. D, bounded. Domain? Yes, it is E, domain. And region? Yes, it is region. That's enough for today. Let us take an attendance and we will finish inshallah ta'ala. The next section, we will start the next section, next class of Mashiach al-Awla. ليش الاتندنس مش راضي يشتغل؟ ايه what happened؟ أعوذ بالله من الشيطان الرجيم. Yeah, now it's working. Okay, can you enter the attendance code and thank you for your time?